today's lesson is adding rational numbers. So there's the title, adding rational numbers. And our first example is decimals. We're going to add negative 5.14 to positive 3.78. Step 1. I recognize since I am adding opposites, a positive to a negative being opposites. Since I'm adding opposites, I subtract the absolute values, which means in my head I'm ignoring the fact that that 5.14 is a negative. Its absolute value to me is that it's 5.14 spaces away from 0. So its absolute value is 5.14. So I'm actually going to do that. 5.14 minus 3.87. And here's where the class is going to have to help me to make sure I don't goof it up. 4 can't take away 7, so I'm going to do a borrow. That's now 14 minus 7 is 7. 0 can't subtract 8, so I'm going to have to do a borrow. 10 minus 8 is a 2. The decimals line up when I'm using this method. And 4 minus 3 is now 1. So my answer is 1.27. But I need to now go to step 2. Step 2 is decide whether result is positive or negative. Some of my class doesn't write quite as fast as me, so I'll slow down a little on the writing and talk a little bit about how I make that decision. Again, I go back to the original question up here and think, well, that was a negative, that was a positive, and this one here had the biggest absolute value. Maybe in grade 7 you learned to think of it as this one's farther from 0. That's why the final answer is going to be a negative. So the final answer is a negative. Give my class a second to catch up to me. Fun. All right, we're back. Please note, I always point out to students at this point that this is the way you've been doing this for a couple of years. I always point out to students that this isn't really any different than thinking negative 5 plus 3 in my head is really just 5 minus 3 with a negative on the answer. Right? I think 3 of these positives cancel 3 of those negatives. There's 2 negatives left behind. So that's the exact same reasoning I used here as to why this is a negative for an answer. This is not as many positives as this is negatives. So it makes sense that there's negatives left behind. So that's how we approach decimals when they're opposites. What about when they're not opposites? Example 2, here we'll chunk this a bit. Example 2, what if we just add 2 positives? Well, if you don't need to go to columns, I'm very happy with you just trying to do it without columns. Just make sure you do it right. Because on the second test of the year, you will have to deal with some decimals without your calculator. We'll never go worse than 2 decimal places, like this example. So if you need columns, do it. If you can do it without columns, I'm fine with that. Let's see if I can do this without columns. I know that a 9 plus a 1 is going to be a 0, but it's going to add another tenths. So that's now a 2, 1, and a 1 is 4, and then decimal and 12. And if, of course, your answer doesn't have a 0 there, you don't really need it. Doesn't add to any of the value in the question. So it is 12.4. Remember from old integer skills, a positive plus a positive is still equal to a positive. So there's the second example. Much easier than the first, isn't it? I didn't have to worry about subtracting. Same thing with example 3. Example 3, what happens when you add a negative to a negative? Well, again, since I'm adding negatives to negatives, I'm going to get a negative answer. And I can just add these numbers together. Let's see if I can do this one without a column. 18 and 25. 30, 40. Is that 43? I think it is. And 11 and 5, 16. If you couldn't do that in your head, your mental math skills just weren't up to it, then by all means, just add them together. But don't forget, you have to line up the place values. This 5 and this 8 add together because they're both hundredths. Carry 4, and then 6 and 1. And the answer is a negative because I added 2 negatives. All right, and now we better start looking at some fractions. So example 4, we're going to do 2 different ways. This class, I forget, I think we called this one the Fazia method. The other class, I don't remember what I called it. I forget who put up their hand. Maybe might have been the Julia method. But it's the method where we actually change the number to an improper fraction. I do want to point out it doesn't matter whether I look for the common denominator first and then switch it to improper fraction, but I almost always go improper fraction first. So 2 times 3 plus 1 is 7/3. This is a negative value. And 1 times 4 plus 1 is 5/4. This is a positive value. But I can't add them until they are in a common denominator. The common denominator of 3 and 4 is 12. Now, I had to times 3 by 4 to get to 12, so I have to do the same thing to the numerator, so it's negative 28. I had to times 4 by 3 to get to 12, and 3 times 5 is 15. So now I'm thinking, what is negative 28 plus 15? Or again, I usually think of it as 15 positives cancel 15 of these negatives. How many negatives are left behind? And the answer is negative 13, but they're still 12ths, which means now my final answer in mixed number form is negative 1 and 1/12. 1. The other way to do this question, method 2, I forget who we gave this one to. Oh yes, in this class it was the SAM method. Method 2 is to not change to an improper fraction and to just treat this as negative 2 plus positive 1, in other words, the whole parts, plus negative 1/3 plus 1/4 fraction parts. And why is this a negative number? Because this negative belongs to the entirety of that value. It is 1/3 left of negative 2 on a number line. So that negative is for all parts of the number. So negative 2 plus 1 is negative 1. This still needs a common denominator. It's still 12ths. And that's negative 4/12 plus 3/12. So I now have negative 1 plus negative 1/12, which is same as last time, negative 1 and 1/12. Like I was telling both classes, it doesn't really matter to me which way you choose to do these questions, method 1 or method 2, as long as you're getting them right consistently and as long as you pick the method that works best for you. Honestly, a strong grade 9 student should be able to understand both methods and use either one. That's enough for you to now try chapter 3.2. The first few questions I'm actually going to assign, I already put it on homework online, are, hold on, homework online. This is where everybody watching this on their computer gets dizzy. There we go. Numbers 3 to 11 is a good way to start. After that, we'll have to do a little more examples, but that's enough to get you going on 3 to 11, which will be due sometime next week after the Strong Beginnings days.